So today we are going to be going over this present value of flows in geometric progression equation, also known as a geometric gradient. So what do we mean by a geometric gradient? Well, unlike an arithmetic gradient, instead of going up by the same dollar value every time, it's going to go up by the same percentage each time, which means that the dollar value is going to go up more and more each time because it's a percentage of what we paid last time, essentially. So here's an example. A debt is to be paid off in 5 years with the first payment of $2,400 to be increased by 15% annually. The annual interest rate is 8%. Determine the current amount of debt. Okay, so therefore, what we're trying to find is we're trying to find the present value. We're not trying to find some amount of debt we'll have in the future or when the debt will be paid off or things like that. We want to know how much debt is there currently today based on the information we've been given. Okay, so first I'm going to just write down all the things that are given to us. So A means the annuity amount, so the amount being paid consistently each month. In this case, this is going to be equal to the first payment because, as we know, this is going to increase over time, and that'll be accounted for with G, the gradient, when we get there. So A is equal to 2,400 since that's our initial payment. Okay, the next one is N. And n in this case is going to be the number of compounding periods. In this case, that is going to be, let's see. Well, it says it's going to be paid off in 5 years, and then a payment is made each year. So therefore, we're going to go with 5 for n. All right, then we have g, which is the gradient percentage. Notice this is a lowercase g instead of an uppercase g. And the reason for that is because the uppercase g represents the amount up that we're going each time when we're doing arithmetic progression. But in this case, g is not a specific number value, it's a percentage. It's 15%. And then I is the interest rate. And the interest rate in this case is 8%. Now, if we were doing this monthly, we'd have to divide by 12, or if we were doing this quarterly, we have to divide by 4. But in this case, we are making annual payments, and so we can just stick to the annual interest rate. That's good. Okay, so now what we're going to do is we are just going to plug all this in and see what we get. So present value is equal to 2,400 times 1 plus g, so 1.15 to the power of 5, 1 times 1.08 to the power of negative 5 minus 1, all over 1.15 minus 1.08. So essentially the difference between the gradient percentage and the interest percentage. Okay, now let's grab a calculator and do it. So first we're going to start with the numerator, then we're going to divide by the denominator, and then we're going to multiply by 2,400, very last step. So let's start with 1.15 to the power 5 equals times 1.08 to the power of negative 5, hit equals again, minus 1 equals, and then we can just divide by 0.07 since we know that that is what the result of 1.15 minus 1.08 will be anyway, hit equals, and then multiply by 2,400, hit equals again. Okay, so therefore the present value of this loan is $12,647.86. So there we go. As always, feel free to leave any questions you might have in the comment section, and we'll see you for the next one.